Hello, everyone. We're back to solve with substitution this time around. We're taking the same system of equations we solved with graphing, and this time we're going to handle it algebraically because, as you're aware, sometimes solving systems by graphing is not going to be feasible. Maybe you're not given a graph. Maybe the numbers you're given to work with are a little weird. Maybe that's just not your preference. Maybe you have a hard time with graphing. For whatever reason, understand that solving systems done in any of these three different ways we're talking about gets you the same result. It gets you the place where the x and y values for the two lines is the same. That is to say, the place where the lines meet, intersect, cross touch, whatever you want to call that. Okay? So, solving with substitution. You'll notice here step one says we have to solve one of the equations for either x or y. So what that tells you is that solving for substitution is really easy when one of the equations in your system is in slope-intercept form, like the one you see here. It says y equals 5x minus 2. That's already taken care of for us, right? We know that the value of y in this case is that it is equal to 5x minus 2. Is that a number value? No, but we will be able to use that to find a number value once we get to the second step. So if you are given an equation where one of the variables is already solved for, whether it's in slope-intercept form and y is by itself, or the equation has x by itself, substitution is going to be the way you want to tackle that system because it's set up to solve with substitution most easily. All right. Now, step number 2 says that we need to substitute for y in the other equation and solve for x. So because we're given this value of y, because we know it's equal to 5x minus 2, we're going to substitute that in to this equation here. Instead of saying negative 2x plus 2y, we're going to substitute in for y 5x plus 2, or sorry, minus 2. Okay? Because we know that's what y is equal to, we can go ahead and just substitute it in. And now that we've done that, we've created this algebraic equation where, let me get this cursor out of the way, or maybe over here is better. We've created this algebraic equation where we only have one variable to worry about instead of two. So now if we solve this, we'll get a number for an answer. That's going to start by distribution, right? We know that we should get rid of these parentheses and simplify this problem by distributing 2 from outside the parentheses to everything inside. And that's going to turn into negative 2x. 2 times 5x is 10x. And 2 times negative 2 is negative 4. And that equals 12. One more thing we can do to simplify the problem is combine our like terms. In this case, that is our negative 2x and our positive 10x. And we can put those together and bring us 8x minus 4 equals 12. Now that the problem is as simple as possible, we're going to go ahead and solve it. And we're going to do that drawing our line under the equal sign. We're going to get rid of this term here that's not doing anything for us, right? We know that we have negative 4x. Just kind of floating off on this side there, not really attached to x at all. So we're going to get rid of it by adding 4 to both sides. I think I said 4x before, I meant 4. All right. Those negative 4 and positive 4 are going to cancel out, and what's left is 8x. Over here on the right side, we got 12 plus 4. That's going to get us 16. One last thing to do here, and that is divide both sides by 2. And that's going to get us x by itself on the left side. I said divide by 2. I got ahead of myself. I meant divide by 8. Let me go ahead and fix that. And the reason I said divide by 2 there, as I'm sure you caught on, is because 16 divided by 8 gets us 2. So I was doing the math in my head and kind of spilled out. I apologize for that. So by this process of substitution, what we found is that we can actually find a number value for one of our variables, in this case x. And now we know that x is equal to 2. And that's going to be true in both of our equations. So for step 3 here, where it says substitute the value of x into one of the equations and solve for y, because we know x in the first equation is the same thing as x in the second equation. That's what we're we're looking for in that solution, the place where the x's are the same and where the y's are the same. It doesn't really matter which of the two equations we plug our x value back into. And because that first one wasn't slope-intercept one, was already solved for y, I think that's going to be the easiest path forward for us. So we know x is 2, and so we can substitute that in, and we can go ahead and we can simplify and solve. 5 times 2 is going to turn into y equals 10 minus 2. And once we're done here, we're just going to go ahead and simplify 10 minus 2. That's going to get us 8. So, just like before, just like the solution we found with graphing, we're given this pair of x value and y value. And because we're dealing with the same system, the solution is exactly the same. The place where these two lines cross is going to be at this point. 2, 8. And remember, no matter which way you do this, you're going to end up with the same solution every single time. That's because all these methods are different ways of finding the same exact thing. So it doesn't matter which way you choose, and most often you're going to choose the method you're most comfortable. If you prefer graphing all the time, do graphing all the time. Substitution, do substitution. But whichever method you use, as long as you're consistent and you're following the steps correctly, you're going to get the right answer. And you should remember that you can always check your work by just plugging in your x and y to both of the equations to see if it makes them both say something that is true. Now, again, we did that in the first video, so I'm not going to touch on that here, but just know you always have that as an option. All right, so that's graphing, and now this is substitution. In the last video, we're going to talk about the final way you can solve these systems of equations, and that is going to have to do with elimination. So I'll see you over the next video.